Hi everybody. Today we're gonna make snow using something called the common ion effect. I'm using this experiment because in Southern California where I live, we never get any snow, even in winter. So today we'll make snow that we never get in a beaker. Now, before we go on to the experiment, let's know a little more about the common ion effect. The common ion effect happens when you try to dissolve a less soluble salt, in our case, table salt, in a solution of a more soluble salt, in our case, HCl or hydrochloric acid, and they both share a common ion, in our case, chloride. Let's show you an example of the common ion effect. So, let's take limestone, aka calcium carbonate. Calcium carbonate is poorly soluble, and when dissolved in water and some of it remains, it goes in equilibrium between calcium ions and carbonate ions, turning to calcium carbonate, and so on. As this happens, the process will attain equilibrium, and it will keep going until something affects the equilibrium. Let's see what happens when we add something that will affect the equilibrium. Here, let's do the same thing, dissolving calcium carbonate, but this time in an already prepared solution of sodium carbonate. Now, guess what happens when I try to dissolve this block of limestone in a sodium carbonate solution? Check out this video, which is the equilibrium video, for a hint. Well, if you watch the video, you can see that the solubility of calcium carbonate will decrease. That's because we can, with sodium carbonate in solution, we can see that the carbonate concentration goes up. And because of that, the equilibrium will shift to this side, making the carbonate ion wanting to go back to calcium carbonate, and therefore decreasing the solubility. Let's look at our experiment. Our experiment is also called salting out, where it is used in industry in such as the processing of soap. Here, we'll use a less soluble salt, which is sodium chloride, more soluble hydrogen chloride, and the common ion is chloride. Why sodium chloride precipitates is because sodium chloride solutions can reach up to 6 molar. Since sodium chloride's molar mass is 58.44, we can see that in a liter, about 348 grams can dissolve. 350 grams can dissolve in a liter of water. However, HCl is more soluble at around 12 molar. And because of that, the sodium chloride will just crash on a solution. Now, let's move on to our experiment and make a snow globe in a beaker. See you there! Now, let's do our experiment, snow globe in a beaker. First off, let's pour our saturated salt solution. Saturated just means that you can't dissolve any more of a substance into a solvent, in our case, water. So saturated sodium chloride means that you can't dissolve any more sodium chloride into water. Next, we add hydrochloric acid. Remember, this stuff is corrosive, so handle it with respect. Ready? How did you like the reaction? The reaction, as I said in the explanation, caused the common ion effect to happen. This created sodium chloride precipitate, and it looks a lot like snow, isn't it? You can always swirl it and then it will fall right back, just like a real one. For the cleanup, it is simple chemistry, just add baking soda. The baking soda will react with the hydrochloric acid to form salt, which is more salt, and water, along with some bubbling. Also, perform this experiment in a well-ventilated area because hydrochloric acid is HCl dissolved in water. HCl is a gas at room temperature and it may release fumes. This is why you should do this in a fume hood, well-ventilated area, or outside. Now, let's do the cleanup. Ready? So, let's get some baking soda and add it. You can immediately see the bubbling occurring. It's just the same stuff that we saw in a colorful eruption with bubbles in it. And by the way, for the experiment, you'll need 50 milliliters of concentrated hydrochloric acid and 100 milliliters of saturated sodium chloride. My calculations say that for the cleanup, about 48 grams of baking soda will be needed. Did you enjoy the salty snow globe experiment? Thanks for watching, and see you in our next holiday experiments. Bye!